This video is about special right triangles, but now we're going to move to finding exact values of trigonometric ratios when we're given measurements in degrees. All right. Now I've written down here a series of steps that you can reference back to. Okay. But one of the key elements here is we're going to have to first kind of set up the triangle that we need to see. Then we're going to apply steps 3 and 4, which is these two pictures right here. If it's a 30, 60, 90 or a 45, 45, 90, we are always going to assume that the hypotenuse is 1. That relates back to something that is called the unit circle that you're going to really dive into when you're in pre-calc. Okay? We're then going to find the ratios and simplify. So use this right here, this page that I have showing right now, as a reference for when you're doing these problems, and it should be pretty clear and pretty straightforward. Let's jump in right here. So what do they want us to find? They want us to find the sine of theta. Okay? The first thing that I want to do here is create a right triangle using the terminal side and, in this case, the negative x-axis. So there's my right triangle. Okay? The hypotenuse is always going to be 1. This angle down here is theta. Now, knowing theta is right there is very important because we're going to use that when we go to find the sine of theta. Okay? So if that's theta, we're good. I know that this terminal side, negative 210, is 30 degrees above the x-axis, the negative x-axis. And that gives us a 30, 60, 90 right triangle. When the hypotenuse is 1, so again, we're using these reference triangles here. When the hypotenuse is 1, I know that shorty is 1/2, and I know that 60 is the square root of 3 over 2. But I moved negative on the x-axis. So it'd be negative square root of 3 over 2. Why is the 1/2 positive? Because we're moving up from the x-axis. Up is positive movement. Once I have this, I'm ready to find the sine of theta. Now, theta that they give me is negative 210 degrees. But I'm going to reference back to this triangle to figure it out. From theta, I know sine is defined as opposite over hypotenuse. So this would be opposite, 1/2, over hypotenuse, 1, and the exact angle measurement, or the exact trig measurement of the sine of that angle is 1/2. Let's try this one now. Okay, I've got my terminal side, and in this case, the positive x-axis. Creating a right triangle, there's theta, and the hypotenuse is 1. Now, if I look at a negative 660 degree angle, I know that the terminal side is 60 degrees above the positive x-axis, creating, again, a 30, 60, 90 scenario. If the hypotenuse is 1, shorty is 1/2, and it would be positive because I'm going on the positive x-axis, and the longer side would be the square root of 3 over 2 because I'm moving up from the positive x-axis. Okay? Once we have that, we're ready to find the cosecant of negative 660 degrees. I'm going to reference back to theta. Now, I know that cosecant is 1 over sine. All right? So the reciprocal of sine. I know that the sine would be square root of 3 over 2 over 1. Opposite over hypotenuse from theta. But I have to do hypotenuse over opposite. Now, from here, I'm going to have to simplify and rationalize if necessary. If I simplify this, I get 2 over the square root of 3. All right? Now I'm going to rationalize this to 2 square root of 3 over 3. And this is the final exact answer. Notice, when they want exact, they don't want decimals. They want everything written in a simplified radical form. All right? Or a simplified form. Let's try the cosine here. Sketch my triangle. Terminal side, positive x-axis, and forming a right triangle with the hypotenuse is 1, and theta is always back at the origin. All right? Now I know that positive 315 is 45 degrees short of the axis. This creates a 45, 45, 90. I know that the two legs are the square root of 2 over 2. The one on top here is going to be positive square root of 2 over 2. But the one going down here would be negative square root of 2 over 2. Why is it negative? Because I'm going down from the x-axis. All right? I'm now ready to find the cosine of theta. Now the cosine of theta is, remember, we got to come back here to theta. The cosine of theta says adjacent, square root of 2 over 2, over hypotenuse. And if I simplify that, I get the square root of 2 over 2. Done. Let's try one more just to make sure. We'll do one in the third quadrant. Terminal side, negative x-axis, creating a right triangle. Hypotenuse is 1, and there's theta. If it's negative 150, that means that it's 30 degrees short of that axis, creating a 30, 60, 90. Shorty is 1/2, but we're going to say it's negative 1/2 because I'm moving down. And long would be the square root of 3 over 2, but I'm going to call it negative square root of 3 over 2 because we're moving left from the origin. I'm now ready to find the trig, the tangent of negative 150. Well, again, from theta, tangent is defined as opposite, negative 1/2, over adjacent, negative 3 over the 2, negative square root of 3 over 2. This can be simplified. All right, first of all, a negative divided by a negative is a positive. So I know that the answer is going to be positive. And if I simplify this by either multiplying by the reciprocal or doing big C, little c, I would get 1 over the square root of 3. I need to rationalize this, and I get the square root of 3 over 3. And that's the actual measurement of the tangent of negative 150 degrees. I hope this helps. Let me know if you have any questions.